Welcome to the October 1991 KCP News video. On June 13th, in response to a court decision putting the future of the Kemano Completion Project in question, Alcan started to slow down operations. Eventually, that slowdown became a full-fledged suspension of almost all construction activity on this $1 billion project. While Alcan makes every effort to get this project back on track, hundreds of workers, engineers, and managers have left Kemano. Most of the heavy equipment, though, has been mothballed on site, ready for an orderly resumption of construction activities when the project resumes. To give you a better understanding of the situation we're facing, here's Alcan's Vice President for British Columbia, Bill Rich.
As this will be the last news video until work resumes on the now suspended Kemano Completion Project, I want to take this opportunity to make a few comments about the project and what lies ahead as we make every effort to get it back on track. First, I'd like to review briefly the events of this spring. In May, a decision by Mr. Justice Walsh in the Federal Court of Canada ruled that the Kemano Completion Project must undergo a federal environmental review. In his judgment, he quashed the 1987 execution of the Kemano Settlement Agreement, which had secured for Alcan the conditions under which we could carry out construction and operation of the project. This agreement, which had been signed by both the federal and provincial governments, spelled out everything Alcan was required to do during both the construction and the operation of this final phase of our Kemano project, both from the perspective of environmental protection in general and the fisheries protection program in particular. Both governments had initially approved our project 40 years ago, and as many of you know who worked on it, most of the major physical elements of the power generation system have been in place for decades. The 1987 agreement was really about the modern environmental improvements which Alcan agreed to make to an old design. It was not approval for a new project. And to confirm that view, the federal cabinet passed an order in council directing that the federal review process for new federal projects did not apply to Kemano Completion. Justice Walsh quashed that cabinet order in council as well, an unprecedented action by a court. The Walsh ruling was carefully considered by Alcan management. However, it created so much uncertainty about what we were building that it was decided that the prudent course was to halt additional spending and keep current spending to a minimum. Alcan very much regrets the decision it has been forced to make. KCP is a good project, and we had good people building it. Those of you who've worked on it know firsthand the top quality of the work being carried out to a very high safety and environmental standard. I'd like to emphasize that Alcan is not afraid of an environmental review, and we have nothing to hide in the project. The design changes for Kemano Completion were rigorously reviewed by government environmental specialists, and the results were widely publicized. If a further formal public review had been required by government, we could have complied long before construction started. But in our view, business is in an untenable position in this country if the rules can be changed in the middle of the game. We have a right to know what the regulations are, and we are entitled to rely on the approvals that government issues. If you had the building permit canceled when your house was half built, you would fight, and so will we. Both Alcan and the federal government are appealing the Walsh judgment. The appeal is scheduled for mid-December 1991, but we do not know how long it will take to get a decision. We can see that it could take easily 24 months from Alcan's June decision to slow the work on the project before all the court processes are complete, and that's assuming there are no other glitches or delays along the way. In the meantime, because of the court order, the federal government has begun a further environmental assessment of the project, starting with an internal review. Again, we have little knowledge as to how long this will take, nor what the outcome will be.
In this edition of the KCP News video, before the shutdown, the Kemano Completion Project was rolling along in high gear as the underground work moved from the excavation stage to the structural stage. In the mountains, work is wrapping up on the new Tatsa intake. and we get a first-hand look at one of the largest marine blasts in BC history. From the very beginning, KCP has made safety the #1 priority. In this news video, we'll meet the safety team. And after more than a year of boring through 8 kilometers of granite, the tunnel boring machine finally holes through. But first, our progress report. Although it's deserted now, in early July, the underground powerhouse excavation was teeming with activity. All of the major drilling and blasting on the powerhouse excavation was completed by the end of May, and Mount Dubose was bustling with heavy equipment and trucks servicing the first stage of structural construction. Most of the work taking place at the time was building forms and pouring concrete for the pump and inlet valve galleries. The transformer gallery was already fully excavated, as was the new powerhouse. Between the two caverns are a number of tunnels to accommodate conduit between the transformers and the generators. The lower tunnels, part of the tail race manifold, were among the first elements completed. Soon after PCL Northern completed rock excavation, concrete pouring began. Among the first jobs was leveling the rock floor of the excavation. With that complete, the powerhouse was ready for the addition of structural elements such as walls. The bottom level of the powerhouse is where water will drive the new turbines. Before the shutdown, workers here were constructing the runner pits which will channel water from the penstock through the turbines and into the tail races. 100 meters or so deeper into the mountain, work was well underway on excavation of the new penstock, a shaft 4.25 meters in diameter that will carry water from the power tunnel downwards at a 46-degree angle to the turbines in the powerhouse. The principal piece of equipment on this operation is called an Alimac raise climber. Essentially, it's an articulated trolley suspended from a track on the top side of the penstock raise. The Alimac is powered by a diesel engine that drives it at roughly 27 meters per minute. Two of them are used in each excavation. The lead Alimac provides the actual work platform for the 3 drills and crew. Following it up the raise is the alley cab. This vehicle transports crew and supplies. Once in position at the rock face, the crew transfers to the Alimac work platform. Supplies are winched in a basket from the alley cab to the Alimac. Directional guidance for excavation in the penstock raise is provided by a survey team using a laser system. Once the correct angle of attack has been established, a series of 3-meter holes are drilled. Next, explosives arrive on the alley cab, are transferred to the rock face and loaded. The crew and Alimac then retreat, and the round is detonated. While the muck is cleared from the bottom of the raise, the Alimac climbs to the face and the crews begin work again, scaling the rock face, adding rock bolts, extending track and ventilation units, and drilling the next round. The plan for the penstock excavation involved drilling and blasting in 2 simultaneous operations. One, beginning at the base level of the powerhouse, had progressed 340 meters upward on the lower leg of the penstock excavation before construction stopped. Another Alimac team entered the mountain at the 500-meter level and began working upward from there. Eventually, the two shafts will be joined to form one. Down in the valley near the maintenance center, a new concrete batch plant was constructed. With a production capacity of roughly 100 cubic meters an hour, this plant was feeding a steady stream of cement trucks bound for the new powerhouse. In the village of Kemano, the new sewage treatment plant is in operation. With the addition of a number of new homes and a new apartment building, the old system was simply overloaded. This plant, installed by the Kemano Completion Project and managed by Rod McCabe, promises state-of-the-art operation.
It's an activated sludge plant, which is an aerobic process. All we're essentially doing is speeding up Mother Nature. The sewage
How?
comes in...
By adding more of the same bacteria already at work in the natural process. This facility has a maximum capacity of 230 cubic meters of sewage a day. At the moment, though, it's operating at only half that. According to Rod, it's also a very clean plant, 3 times cleaner than demanded by its government environmental permits.
The effluent, which is about 99% of the flow, goes through an ultraviolet disinfection unit and then discharged to the river. The other 1% of the flow is digested, that's the sludge. It's stabilized and then trucked away.
With so much new construction taking place in the village over the past year, the landscape was looking rather barren. From the looks of this operation, someone's solution seems to have been painted green.
Okay. That's it. Stop.
Actually, what this crew is doing is spraying a layer of liquefied mulch fertilizer over the already seeded ground. This provides a rich environment for germination of the grass seedlings while protecting them from birds and wind. On the Kitimat side of Kildala Pass, clearing operations on the transmission line right-of-way shut down along with the rest of the project. Last year, logging crews harvested around 115,000 cubic meters of timber. This year, the big job was to finish transporting that timber to Skena's sawmills in Terrace and to clear all non-marketable timber from the right-of-way. Although this operation was much like any logging job, there were some special considerations for the environment.
We're standing here in the Kildala Valley outside Kildala Camp 2, having a look at the new transmission line that has been logged and has been cleared. What I have behind me here is an environmentally sensitive area called a buffer zone. There have been 32 areas identified on the transmission line as buffer zones. We've tried to maintain a 20-meter optimum setback from any rivers, watercourses, marshes, or wetlands for these buffer zones. There are several reasons for the creation of these buffer zones. The first one is to provide habitat enhancement for the fish populations. Secondly, it's to provide shelter and a food source for wildlife. Thirdly, aesthetically, it looks more pleasing. And fourthly, it satisfies concerns of government agencies. And the fifth one is maintaining stream bank stability. Looking at the buffer zone behind me, you can see that the markings on the trees indicate the right-of-way boundaries, and that the buffer zones are actually flagged in orange and blue tape.
Back on the Kemano side of the pass, logging on the transmission line right-of-way got underway in the middle of May. Because this operation was looking at a completion date of early July, and because it was producing revenue from timber sales, it continued after the rest of the project shut down. During this period, logging trucks were a common sight on the road to Kemano Bay. This is where the logs began their sea journey to the mill. They were assembled into log booms here, then towed by tug roughly 80 kilometers to Minette Bay near Kitimat. Then they were loaded onto trucks once again for the trip to Skena sawmills in Terrace. Also in Kemano Bay, the new barge ramp was seeing a lot of traffic, with outgoing equipment from the powerhouse excavation and incoming equipment for the structural work. Bulk loading and storage of dry cement at the port, was being facilitated by a new cement silo installed by the powerhouse contractor PCL Northern. In Kitimat, a new laydown area has been established. At the time of shutdown, it was crowded with structural steel for construction of transmission towers along the new right-of-way. In the mountains, another port operation was busy this summer. By the end of May, the new West Tatsa camp was completely mobilized and home to more than 60 people. This is the staging area for work on the new Tatsa intake, a short distance away over the water. Like the original intake 500 meters away, this one will control the flow of water entering the power tunnel for the 16-kilometer trip to the powerhouse in Kemano. Work at this elevation can only take place during the short summers. It will continue until this stage is finished, probably in October. To service the worksite, PCL Pacific Contractors commissioned a new landing craft. Aside from a couple of small boats, this is the only way to get equipment to the site. As well, much of the drilling work is being done from a barge. The primary job this summer was the drill and blast excavation of the adit and the underwater approach to the new tunnel intake. Work must progress quickly at this site. Sandifer Road, the only land access to the site, is expected to be closed by snow as early as October. On July the 10th, a major milestone was passed, virtually ensuring that this deadline would be met: the underwater blast clearing the approach to the new tunnel intake. We'll have the complete story on the Tatsa blast a little later in this video. One of the main focuses of the Kemano Completion Project was the emphasis on safety. As the man responsible for planning and managing the safety program at Kemano, Art Cannon insists that safety awareness is a priority.
KCP emphasis on safety has been second to none. Alcan and Bechtel combined join the design, engineering, planning, and distribution of responsibilities, took every necessary precaution to assure safe working conditions for all employees working in Kemano.
This valley that we have going to one of the work sites from Kemano Village up to Heretsky Camp, that's where the adit is that's being driven in.
Alcan has spent a considerable amount of money
Both ways from that.
on safety in the Kemano Valley. For example, we have a very well-equipped indoctrination center. We have emergency vehicles. We have a well-equipped first aid clinic with all related material. We have spent over $750,000 on emergency equipment. The KCP Safety Department consists of 4 senior safety representatives, a registered nurse, 3 first aid attendants covering the Sequokin nursing station 24 hours a day. In addition, each contractor in his specific area of work has a first aid clinic, first aid attendants 24 hours a day, and a safety department with supervisors on each shift. We have several emergency response teams organized in the Kemano Valley. We have teams for mine rescue. We have teams for mountain rescue. We have teams for avalanche rescue. We have a volunteer fire brigade. And we also have a security team that covers the camp 24 hours a day. And within these emergency response teams, we have qualified first aiders that are an integral part of each one of those teams. Every new employee that arrives on the Kemano Completion Project must attend an indoctrination session. He is given a safe practices manual which explains his responsibilities regarding accident prevention. The session takes into consideration the hazards involved in each specific trade and also allows us to conduct a risk analysis jointly with the worker related to hazards involved in his own trade. We also explained to him in great detail the rules and regulations that are being enforced in the Kemano Valley. We also explained to him in detail his right to refuse to work because he has a very specific responsibility to follow all rules and regulations. If he does not know, he should ask, and we ask him to continue a constant dialogue with his supervisor to assure safe working conditions at all times. The manual also allows him to conduct a risk analysis of his own aspect of work before the commencement of each shift, and assists him in assuring safe working conditions for himself and his co-workers. As I mentioned earlier, one of the key elements in our safety program is the emergency response teams. We have one team in mine rescue led by Jerry Palm, who has 21 years of experience.
The situations here in the Kemano Completion Project, which would call for a mine rescue operation, would be a fire underground. We got a possibility of a fire. We've got a possibility we could have a cave-in anytime you work underground. And we also have a penstock here, a long penstock where men could be trapped and we could end up responding to an emergency. Mine rescue team training on the Kemano Completion Project consists of a minimum of 4 hours training for each team. In that training, they actually wear the apparatus, go into the underground operations, and we also like to simulate actual rescue scenarios.
There's been a fire reported in the air supply tunnel, and we have to go down. There's one man unaccounted for. I believe it's a Teamster. He dropped off a load of explosive, and he was on his way out when the fire was reported.
The call comes into the contractor's first aid, and then he notifies the construction manager, who gets a hold of the safety department, who calls out the mine rescue team. They respond to the mine rescue room, where they're briefed by the safety department and the mine rescue team captain. From there, they check out their gear.
Number 6, okay. Number 5, okay. Number 4, okay. Number 3, okay. Number 2, okay.
Ready for your negative pressure test?
A mine rescue team is made up of 6 members. The number 1 man or team captain, some of his duties or qualifications, he's got to understand mine gases. He's got to be able to read plans. And most important, he's probably got to be a good leader of men. He's got to have a qualification to lead people. The number 5 man or vice captain, his qualifications are much similar to that of the captain. And in addition to that, he's there to watch out for things that the captain might have missed and also watch out for the rest of the team. 2, 3, and 4, they're the workers of the team. You'd want an electrician, first aid man, miner, and maybe somebody with some mechanical experience. The number 6 man, he's a fresh air base man. He looks after the fresh air base and equipment, and he communicates with the team over the telephone. When the captain calls out, he records information and passes on any information.
Bench test complete and okay. Don, your apparatus team?
Safety of the team is of the utmost importance, so they do a thorough bench drill. This takes approximately 25 minutes, and it's serious. It's very military-like. They move from there to the portal. When they get to the portal, the team captain checks his team, checks them thoroughly to make sure that all their apparatus is functioning and that the team is okay before they enter. The priorities upon entering the tunnel or the underground operation is safety of the team. So they're watching various elements on their way in. Proceed until they find a problem which could be a fire, as it is in this situation. They respond to the fire by putting it out and checking it, and they go on further from that point and they find the patient. They tend to his first aid needs, and in this case there's a lot of smoke, so they put a mask or a breathing apparatus on him, and they bring him out to surface. Team discipline is of the utmost of importance in a rescue operation. In order to have any rescue operation succeed, you've got to be disciplined. Once they reach surface, of course, the contractor's ambulance has responded to the portal. He's loaded into the ambulance and taken off to our first aid clinic in Seawakin, where he'll be medevac from there. Following that, they return back to the mine rescue room where they attend to their gear, take their gear off, and the captain is debriefed by the mine manager, who will, if another team is needed, brief them before they enter, and it carries on like that. The fundamental principles of mine rescue is safety of the team. And we all realize anytime you run a rescue operation, there's going to be some element of risk, so safety of the team is very important. Second, we want to save lives, trapped men. We're going after trapped men and we want to save their life, get them out. Thirdly is prevent further damage, such as a fire, you want to put the fire out. Fourth is get the thing up and rolling again, rehabilitation. The Kamano Completion Project, in terms of the underground and mining operations, in my experience, is second to none. We got some of the best trained personnel and equipment in the mining industry.
When contractor PCL Pacific Constructors took on the job of building the power tunnel intake at West Tatsa Lake, one of their first requirements was a small navy. This landing craft is being launched at the new West Tatsa camp. The camp has been built as a staging area for equipment and building materials to be loaded onto boats and barges for the trip to the site. It is located at the end of the Sandifer Road on the shore of the lake. The work site itself is 1 kilometer away across the water, about 500 meters from the original intake. While virtually all other work was halted on the Kamano Completion Project in June, this was the one significant exception, so that all major elements of the project can be completed within the required schedule. On shore, drill and blast crews prepare the shoreline rock face for the intake structure. This requires excavating down to a level 24 meters lower than the surface of the lake. At the bottom, a stub tunnel was excavated, approximately 30 meters into the mountain. When the tunnel boring machine completes the power tunnel, it will hole through into this stub tunnel. A few meters offshore, a major marine drill and blast program has been completed. The job here was to excavate a clear approach to the new intake, 12 meters wide on the bottom and 25 meters below the surface. Drilling and blasting took 34 days. Mucking will require about 3 months. Because it's difficult to establish and maintain a position while drilling on water, this barge was anchored using some sophisticated surveying techniques. David Philipchuk, project manager with PCL Pacific Constructors, told us that the marine drilling was considerably more complicated than the onshore operation.
One significant difference is we have very long drill holes in these locations because of the depth of the rock, from the water surface down to the base, the subgrade elevation that we're drilling to. We're drilling in the order of 25 meters in depth. So the control over the straightness of the drill holes and the location of the bottom of the drill hole is very important. So we did undertake a measuring program with an instrument to determine where the bottom of the drill holes were to ensure that we would get a proper break during the blast. Working off of our sectional barge with 2 overburden drills, we drilled in the order of 3,500 lineal meters, or about 2.2 miles of drilling in the rock. Loading casings were put into every hole for subsequent loading of the explosives. All of the loading was done within the last 4-day period. The holes were left empty up until that point in time.
Compared to a dry land blast, a marine blast requires much more explosive. Not only does the blast have to contend with the sheer weight of the rock, it must compensate for the weight of the water above it as well. And in a normal dry land blast, there would be no attempt to break so much rock all in one blast.
We used a product called Hydromex, which is an underwater explosive slurry in cartridges. A total of approximately 22,000 kilograms of explosive was utilized, somewhere in the range of 46,000 pounds. So a tremendous amount of explosive for one blast over a period of 8 seconds. The rationale for completing it in one blast is the fact that you have difficulty seeing what you're doing underwater in terms of doing one blast and then going back and picking up where you left off. Essentially, doing one blast which goes off on a series of delays gives you the ability to cover the whole, encompass the whole area and complete it in one shot.
Once the underwater slope was blasted, mucking operations began. This required a clamshell crane mounted on a barge to pick the muck off the bottom and dump it into a mucking scow. This created a clear underwater approach channel to the shoreline and a deep pocket excavation at the rock face. A rock plug, 17 meters long and 24 meters high, has been left between the 2 excavations. This plug will be maintained until the intake structure is built and the intake gates are functioning. It will then be blasted and mucked away. Before this, though, the pocket excavation will be flooded and the gates raised. This will protect the intake during the blast, as will a curtain of air bubbles introduced to help absorb the shock. Following the blast and then the mucking operation, the gates will be closed and water pumped from the tunnel. Workers will then prepare for the hole-through of the tunnel boring machine into the stub tunnel. As the crews prepared for the underwater blast, they set up seismic sensors onshore and off to monitor its effects. When the time comes to blast the rock plug, that blast will be designed using geological information gathered from this one. At the existing intake, a filter fabric screen was installed. There was some concern that a plume of silt might develop from the marine blast, and that this might get into the working intake, causing problems downstream. As it happened, the resulting plume was very small and the filter screen wasn't needed. At blast time, anticipations were high. This was to be the second largest marine blast in British Columbia history, second only to the famous Ripple Rock blast in Georgia Strait more than 3 decades earlier. In terms of Hollywood pyrotechnics, this was not a spectacular blast. From the perspective of the blast designers, though, it was a success. In their minds, the less spectacular, the better.
Everything essentially went as planned. What we saw was as expected. We had approximately 1.5 seconds of detonation for the surface cord, which was the burning of the cord, which you saw, followed by approximately a 6-second period from the time that the first hole detonated to the time that the last detonated. So essentially, several months' work has come together in approximately 8 seconds.
Hello, I'm Les Holroyd, Alcan's Director of Corporate Information in British Columbia. What you've just been looking at are some pictures of the tunnel boring machine at work inside Mount DeBose here at Kemano in northwest British Columbia. Right now I'm standing at the 800-meter level on Mount DeBose, just in front of the rock face where that tunnel boring machine is due to come through in only a few moments. When it does, it will complete a 1-year, 8-kilometer journey that has taken it from well inside the mountain to where we are now. Let me show you on this illustration. Here's where we are now at the 800-meter level on Mount DeBose. When the drive that's going to end shortly here started, we started from the adit here. Eventually, a tunnel will go in this direction so that water can flow down from the Nechako Reservoir, similar to the project that we built back in the 1950s down here to a powerhouse inside the mountain. The mole men and all those who support the operation of the tunnel boring machine have already celebrated the event that we're waiting for. It's a tradition in this business to have a big party, and in this case, there was no exception. It was complete with speeches and souvenir jackets. While we're waiting for the hole through, let's take a look at an interview we did with Tom Morrison in his office at Heretsky Camp. Tom is the KCP contract supervisor on the TBM job, and he tells us something about the types of rock that the TBM has encountered on its trip through the mountain. So, Tom, this is a sample of the rock that's coming out of the tunnel right now?
Yes, it is. And this is the DuBose stock, which we're in now. We started off in the Heretsky dike, which is relatively soft material, and it then progressed into the granodiorite of the DuBose stock, which became progressively harder into the center of the stock. And as we've come closer to surface, the rock has softened up and become more jointed and altered, and so the progress has actually accelerated again, in spite of the fact that we're now 5 miles from Portal. And there's a very remarkable achievement on the part of the contractor.
Right, right. And despite some of the difficulties you've had with some of that soft rock and hard rock, we're still ahead of schedule.
Oh, yeah, yeah. The difficulties actually with rock have been relatively slight. There was a section back here when the contractor had only just got going, so his operation wasn't really geared up. and he went into this bad rock that had to be supporting steel arches. And that set him back right at the beginning of the job. But he's certainly made up for it ever since.
Right, and certainly the last few days have really moved right along, haven't they?
For the past several weeks, he's been making 35 meters a day, which in terms of a drill and blast tunnel is spectacular. It's pretty good for a bored tunnel.
I know it's hard to be precise, but people are talking about the contractor making record-breaking progress on one particular day.
Yes, there was. The rock was quite soft, and the face was quite close to the portal yet. And there was one day when the contractor drove 80 meters, which is extremely good. And it may be a world record, or it may not, but it's certainly getting on there.
Average over the whole drive was, what, in the area of 25 or 30 meters?
In that order, yes, 25, 28 meters a day. I think the thing that impresses me is the contractor's efficiency, because you have to have a pretty good machine to start off with. But beyond that, it's largely a matter of organization. These guys are very highly organized indeed.
Right. So that speaks highly for the maintenance crews, all the backup and...
Everything, everybody on the job.
Good, great.
Also, I'd like to record that the safety record has been extraordinarily good. Abnormal for British Columbia.
On this job in general, being very concerned about the environment, there are some environmental considerations I know you have on this job. Could you tell us something about that?
Only that the contractor has been very effective in controlling the quality of his effluent, because we take samples of Heretsky Creek above the site and below the site, and there is no detectable difference in the water quality above the site and below the site, so there is no effective effluent.
And this is achieved by a series of settling ponds?
Yes, it is. Settling ponds, and also sprinkling the final effluent onto the muck pile, and so that it discharges to land rather than to water.
You can hear the tunnel boring machine rumbling on its final push through Mount Dubose right now, and I can feel it in my feet. No one is more familiar with this machine and its operation than Gary Davey of Power Mountain Constructors. Gary shares a few insights and figures with us now. Just behind you, Gary, we can see a lot of solid evidence of the work that Power Mountain's crews have done on the tunnel. Can you tell us something about the quantity of material?
Sure thing, Les. Represents quite an accomplishment, as you say. There's about 216,000 cubic meters of material we've removed from the tunnel. And it has a tendency to swell a little bit, and then subsequently when you put it in a pile, due to the compaction effort, it shrinks. That 216,000 cubic meters represents about 27,500 muck cars being brought out by those trains.
It seems like only yesterday that the tunnel boring machine went in there and started this job.
Well, actually, it's a long yesterday. It was about June 18th last year that we started the excavation. So about a year ago, we commenced, and we're virtually near the end of this drive now.
And you're ahead of schedule.
We're definitely ahead of the owner's schedule. A little bit behind my overly optimistic schedule. Like any contractor, you tend to be a little optimistic.
But still very happy with the results?
That's right. In November of 1989, we predicted that we'd be done with this drive on the 18th of June. So if we hold through tomorrow as anticipated, we'll be about 6 work days behind schedule, and I don't think that's too bad of an accomplishment.
When we talk about giving credit on this job, there's a tendency for us to concentrate on the guys who run the machine underground, but you've got a whole team going here, haven't you?
Oh, most certainly. And they need to be recognized. They're part of this overall team. We carry about 33 people on day shift within what we'd call the support group. And that's primarily your shops, your mechanics, your teamsters, first aid people, a bull gang that prepares the material to go underground, the vent pipe, rail, all the support that they need to accomplish their work. So it is quite a bit. As you see in the background, you have to keep handling them up, placing it in the prescribed areas. So this is all ongoing work.
Truly teamwork.
Yeah, and we don't want to leave out of the team the importance of the owner, his representatives, the project performance people, KCP, even down to Cal Van caterers who take care of our men during the mess hall accommodations. You gotta feed them right to keep them happy.
That's right, and you bet the food is good, too.
It is excellent up here.
Could you give us a little comparison of working with a tunnel boring machine and the more conventional drill and blast method?
Yes, given the right machine for the geology, it is far faster. You have a large investment, and so therefore the configuration of the tunnel and the length has to be long enough to write off this investment. The productivity, where we estimate that we will get 92 feet or 28 meters per day, in a normal drill and shoot operation of this size tunnel, they'll get about 3 15-foot rounds, or 45 feet a day. So we're almost twice as fast as a standard drill and shoot operation.
That's a big difference, isn't it?
It allows us to get out, it saves you on overhead, but again, I said it's a big capital investment to set up this kind of operation.
We're going to hole through tomorrow, as you mentioned earlier.
Yes.
What happens to the tunnel boring machine then?
Well, immediately after we get through all the rejoicing, we can start tearing it apart. We'll bring the machine out into the open air beyond the portal, and that allows us to lift the top shield fingers. We'll take that off. Then we drop the side supports, and this frees the machine then to take off the outer segments. This reduces the size of the machine to the extent that it can be pulled back out of the tunnel. While we're doing the mechanical work on the head of the machine out there at the west end portal, we'll be removing all the ventilation fan from in the tunnel, the vent pipes, that's a 42-inch diameter section of pipe, along with the transformers, which clears the tunnel for it to be brought back. It'll be dropped back to 27,250 feet or so, out back here to the Heretsky, where then we'll proceed to turn it around and start refurbishing it in anticipation of doing the upstream drive.
Well, we look forward to that. Congratulations on a great job, Gary. Everybody deserves a lot of credit on this.
Well, thank you, and I'll accept that for Power Mountain and all of our crews, Allied Hydro Council. I think they've done us an excellent job.
We want to share it around. Right.
That's right.
The noise is rising and the vibrations are coming through the rocks as the tunnel boring machine comes near to breaking through. We have a few minutes before it does, though, and we're going to talk to Hal Uhrig, Power Mountain Constructor's safety supervisor. Hal's going to tell us about some of the preparations that were made on the surface so that when the machine breaks through, everything goes the way it was planned.
The hole that you see in the center of the face, surrounded by the red paint, is a probe hole that we drilled 100 feet into the face. That should be intersected by the TBM as it progresses toward the portal, or what we eventually will be the portal. When we intersect that hole with the TBM, we'll survey the hole and ascertain exactly what the position of the TBM is in the tunnel so that we make a proper portal when we finally break out.
So you can adjust it at that stage so you'll come out here at the level you want to be at.
That's right, yeah. The steel rods that are around the perimeter with the plates on them, those are 5-meter bolts. They're put in with resin grout, and those are to stabilize the perimeter of the rock face as the TBM comes through. So as the TBM comes through, however, what you might find is that quite a bit of spalling from the rock face itself, particularly if there's large loose material, which we expect that wedge-shaped piece to come out. Plus you might find, because of the pressure of the TBM itself against the rock, you might find some rock actually being forced away from the face. And what you'll eventually see is the actual head with the cutters coming out through the opening, and then you'll have your opening. That's it.
Right. We've just seen a big chunk of the face of the hole come out. Ed, was that unexpected?
Not really. That's quite fortunate that as little damage is done coming through like that. With the propel that we've had behind us, about 1,500 psi. Really, in all factors, it should have just pushed everything out of there, but it's cutting out nice. It's going to be a nice breakthrough.
That's good. We can hear the voices of your crew in there. I guess they're anxious to get out after a year in there.
They're more anxious to get out this end than they are on the other end.
So the final push is just being set now?
You bet. There's about 3 feet there to go at this particular time. Spent the year with them coming through, and very proud to be the one that started the tunnel, and I'm going to be the one that's finishing it. So.
We're talking to Ken Dixon, project engineer for Power Mountain Constructors on the tunnel at Kemano. We've just had the hole through. Ken, what do you feel?
Well, it's a wonderful day. It's a great day, a great team, and looks like the hole through is right on target.
So there weren't any surprises in what happened today then?
No, other than the large rock in the front, but we can handle that. It came through really smoothly. The guys did a heck of a good job.
So what happens next?
Well, we'll push the machine out into the daylight, and we'll probably have to blast the big rock out of the way, and then a crane will come in and take off the large pieces to get the machine down to a size that we can back down the tunnel and take it all the way back to Heretzky.
Great. Congratulations to you and the whole crew.
Thank you.
Great job.
Thank you.
Well, that wraps up events from here today. Now the crews can get ready to go home. The tunnel boring machine will come out of the tunnel and be ready for its next assignment. Thanks to all of those who made this production possible. We hope you enjoyed this special feature. Thank you for being with us.